Good afternoon everyone. So in this lecture we will discuss the further problems based on EMF equation by using Kc and Kd. So the next problem is a single phase 1500 rpm 4 pole alternator has 8 conductors per slot with a total of 24 slots. The winding is short pitched by 1/6 of full pitch. Assume the distributed winding with a flux per pole as 0.05 Weber and we have to calculate the induced EMF, that is EPH. So very firstly we will write down the given data. So as they have given, go by first line. So they have given a synchronous speed ns is equals to 1500 rpm. Then number of poles, it is 4 pole alternator. Then next, there are 8 conductors per slot and there are total 24 slots. So total number of conductors Z is equals to 24 into 8. Okay. So we will write down there are 4 slots, then there are 4 pole, then number of slots is equals to 24, conductor per slots are 8. Okay. And here the alternator is a single phase. So up till now whatever problems we have discussed, there we have taken the alternator 3 phase. Now this alternator is single phase. Now we have to find out the EMF equation or the induced EMF. Now again we will start with the frequency. We know that frequency F is equals to P/Ns upon 120. By the formula of Ns 120 F by P, we can find out frequency F. So we have P, we have Ns. By putting those values, we'll get the frequency as 50 Hz. Then small n, slots per pole. So there are 24 slots for 4 poles. So n is equals to 6. Then similarly, as it is the single phase, so m is equals to n. Okay. So m is equals to n is equals to 6. As this is the single phase alternator. Okay, so we have to find out the beta. Then the beta is equals to 180 upon n. So n is 6. So beta will got 30 degree. So from this we can find out Kd. By putting all the value, we will get the Kd as 0.6439. Okay. Now we have to find out Kc. Now they have for full pitch, when our coil is full pitch, that for full pitching we require n is equals to 6. But coil is short pitched by 1/6 of a full pitch. So 1/6 of a 6. Okay. So see, 1/6 of a full pitch is 6. Okay, and 1/6. So 1/6 into 6 you have to do. So 6 will be cancelled, which is equals to 1 slot. So our coil is short pitch by 1 slot. Okay. So coil is short pitch by 1 slot. Therefore alpha is equals to beta, and alpha is equals to beta is equals to 30 degree. So put this value in the formula of Kc. So we will get Kc is equals to cos of 30 upon 2. So it will be 0.9659. Okay. So this is the Kc and Kd. Then we have to think for the total number of conductors. Then you know that total number of conductors are conductor per slot into number of slots. So there are 8 conductors in each slot into 24 slots. So it will be 192. Now again our alternator is a single phase. So as alternator is single phase, ZPH is equals to Z. Okay. So ZPH is again 192. Now from ZPH we will find out TPH. So TPH is equals to ZPH upon 2, which is equals to 192 upon 296. So put all these values in the formula of TPH. Okay. And sorry, EPH. And you will get the value of EPH as 662.74 volts. Okay. So this is a somewhat different example with the single phase alternator. And here the tricky part is they have given the coil is short pitch by 1/6 of full pitch. Okay, this you have to take care of. The next problem is a 3-phase star connected alternator has the following data. Voltage required to be generated on OC is 4000 volt. So this voltage they have given is line voltage. Okay, so and this alternator is star connected, so we have to convert the line into phase. So we know that EL is equals to √3 EPH. So we have to apply that formula. So in this problem they have given us the EPH. Okay, then voltage required to generated on the OC is 4000 volt and 50 hertz with the speed of 500 RPM. Now stator slots per pole per phase is 3. So they have given here the value of M. Conductors per slot is 12. Calculate the number of poles and useful flux. Assume all the conductors per phase to be connected in series and coil to be full pitched. Okay, so here coil is full pitched. Coil is full pitch means Kc is equals to 1. Okay, the one thing is clear. Now here Kc is equals to 1. So you just have to find out Kd by using the formula of Kd. Okay, and for Kd you require M and beta. So M they have given 3. See here, slots per pole per phase is 3. So this is the M they have given 3. Then beta you can find out. First you have to find out N for that. Okay, so N is equals to, N is what? Slots per pole. Okay, so slots per pole you can find out N is equals to M into 3. By doing M into 3 you can find out the value of N. So N you will got as 9. Okay, so you have now N, M and beta. You can find out Kd. Kc is 1, Kd you will find out, and then from this you can find out the value of EPH also. Okay, and number of poles you will get from this NS formula. NS is equals to 120 F by P. So we have F also, we have NS also, we'll get the P. So number of poles will be easy to find out. Then next is the useful flux. Then to find out useful flux we will again use this same formula, this formula of EPH. In this EPH they have given, which is a 4000, that you have to convert. EL they have given, you have to convert it into EPH by multiplying it with the √3. Okay, then 4.44 as it is. Kc is 1 for the fourth problem. Kd you will find out. Then F is 50 and TPH also you have to find out by using this data of number of conductors. Okay, and then you will get the value of useful flux. Now you try this problem. Now for today we will finish with this. Thank you.